So we have totally two USB drives, so we're just going to pass it each on one side, and as you do it, we'll just go through the tutorial as well. Hopefully it works. Okay, so welcome to the data table for beginners tutorial. My name is Arun, and I'm the co-developer. Do you hear me now? Do you hear me now? No? Okay. So welcome to the data table tutorial. My name is Arun, and I'm one of the co-developers of data table. And today, Willem will be helping me with your questions, as well as if you have any doubts or anything. So we both will be trying to attend to you if you have any questions. And there's something Willem would like to explain a bit about that.
So I'm not sure if anybody joined the data carpentry, software carpentry thingy this morning, because I actually went to the trainer course, and they have one thing that I really like is with sticky notes, and we will use them here as well. I'll distribute them. The idea is that if you think we're going too fast, you can put up the red or pink sticky notes, and if you think everything is going fine, you can do the green sticky notes. The idea is also that with the exercise that we'll have, you can put up the red ones if you have any issue that you want to be helped out with. And if you're done with the exercise, you can put on the green sticky notes on your laptop or something like that, and then we can easily see if everybody is basically done or has a question or something like that. So I'll distribute them now, and that should help with getting things along.
Yeah, and if you don't have enough sticky notes, just raise your hand, the old school way. If you don't have. Sure. Okay, so so before I start, how many of you have used R or haven't used R? Either ways. So okay, how many of you have used R? Okay, that's great. And how many of you have heard of data table? That's very good. And how many of you have used data table? Okay. Yeah, that's good news so far. So the main author of data table is Matt. He works at H2O, and this is the, well, if the internet works, this is the home page of data table. Sorry. As it works, so we've had, so the first version of data table was released in 2006, and we've had so far about 35 releases, I think 36, and we have quite a lot of tests to check every single time we make a change or implement a new feature and so on. And currently there are about 450 packages that in some way depend on data table. And so the way I measure it is every time I'm giving a talk, I measure the number of packages that has been added since the time I last gave a talk. And as long as it's increasing per month, then that's a good news. So the last time it was 19 packages, and this time it's 22. So it's also the 10th most starred package on GitHub, if that's relevant. And there are about 5,800 questions on Stack Overflow, and it's the third most asked question for an R package. So with this, with today's tutorial, the main objective that I want to focus on is to just get you comfortable with the DT, IJ, by syntax. So if you have never seen this DT, IJ, by, don't worry, you'll see a lot of it today. But this is where the complete focus is going to be, because there are other things that you can also do with data table, like reading a file or writing to a file, or reshaping and things like that, and we'll get to it if time permits after we get through this DT IJ, because most of the operations that we'll be doing in using data table will be involving these square brackets IJ and by. So usually the way I started is before we go, is it working? Yeah. So before we start the tutorial, I usually give this set of exercises, and you're allowed to use R or any other language that you're comfortable with. But given that the number of people here use R, I'd encourage that you use R. And so you have these two data frames, and then there's a set of questions. You don't have to solve everything, because you'll be probably given 12 to 15 minutes, which, if it's possible, you can solve everything, of course. And once you try it out, then we'll go back to each one of these exercises and try to solve them using data table, and hopefully we can compare the differences between the way you have been doing things and how we could do it using data table. That makes sense. Do you follow so far? Yeah. So the USB drives that have been passed around has these exercise files in the disk, but you can just type it out. It's not a lot to type. And then I'll just move to the next slide for you to solve the questions. Is it okay? So it's 2:15 now. By 2:30, we'll just go on with the slides. So just let me know once everyone has gone through this, managed to copy this data, and then I'll move on to the next slide. Yeah. There are 2 USB sticks moving around. Sorry, the first 10, 15 minutes, please bear with us. So for those who have already copied this, I'm just going to copy the first 2 questions here so that you can just carry on with that. If some of the questions are unclear, please feel free to ask as well. Sure. Oh, really? Is it? Okay, perfect. do all of you get this L behind the number? So it just means that you're creating a integer value. So if you remove the L, R interprets it to be a double, a numeric value, as opposed to an integer value. That's the basic difference. So here, 3L, it just creates an integer vector as opposed to a numeric vector. So how are we doing with the USB drive? There's someone behind you.
I think it's like two-thirds of the way.
Okay.
Technology. Yeah. If you don't have it yet, you can try to download it. And if it works, it works. And if not, the USB key is on the way.
Sorry, yeah, I was just going to say that. So for those who came new just now, what we are trying to do is to start with a base R refresher. So you have these two data frames, and the next slides have the questions, and the task is for you to solve them or try to solve them using whatever way you're comfortable with in R, either any package of your choice or even data table or base R. And then we'll go back to these questions and then discuss them using data table. So yes, but there's quite a lot in the next slides. But we'll pass the USB drive. So a large part of this tutorial is going to be solving quite a bit of exercises. So if you're not going to be solving, probably it's not going to be so much fun for you. Who doesn't have the contents yet? 1, 2, 3, 4. Do everyone else have the PDF contents, or just 4 of you don't have? You have? Okay. So there are only 4 more people that don't have. So there's 1, 2, 3, 4, 5 on the back. So where are the 2 drives? Who has them? Could you just pass it through the people? Ah, okay. And the other one, the second one? Okay, could you pass it to the front? Does everyone have the materials now? One more. There's one more. Sorry, who has the USB drives now? Okay, could you pass it behind you once you're done? Everyone who has a PDF, you'll have to continue to solve the exercise 1A and 1B as much as you can. So it doesn't stop with just those 3 exercises. So now that everyone has it, I'm just going to switch to this one so that it's less confusing. So how many of you are using base R to solve these questions? How many of you are using dplyr to solve these questions? Okay. That's okay. Sorry. No, you can. Yeah. So if you've gone through the first 5 questions, then you can just shift to exercise 1B, because we don't have much of a time, and I'd like you to try both the exercises. How many of you have, sorry, how many of you have managed to finish the first 5 here? 4. Okay, even if you didn't, you can move on to 1B, and we'll just stay for another 5 more minutes, and then we'll go on to discussing it. Okay. We'll continue discussing in a minute. How many of you have given up? Okay. Okay, so there are two reasons why this exercise was given. It was supposed to go a little bit more smoothly than the passing of the USB drives. But the first one is to get you familiarized with the data sets, the two data frames, because we'll be using them as data tables throughout this tutorial. And the second one is to use these exercises because each one of them is, in a way, kind of increasing in complexity. So the first three examples, for example, they just are about subsetting rows and selecting columns from a data frame. And then you're updating something to an existing data frame, and then you're grouping by, and then you're having two tables to deal with, and so on. So this is what we're going to see step by step now in the rest of the exercises. So as we go through this, if you have any question, feel free to interrupt. But if there's more than back and forth, then we'll probably have to discuss later. So given this data table, so I've just put the column A here with some different colors to indicate the identical values, and we really don't care about what the values are in other three columns for now. So given this data table, if you think about what kind of operations you'd be able to do with this data frame or data table, given that it's a two-dimensional data structure. So either you can subset rows, so you can say, give me all the rows where column A equals 1, and you'd get just those two rows. Or you could select some of the columns, in this case A and C. Or you could do a combination of both. You could ask, give me all the rows where A equals 1, and give me only the A and the B columns. And what you can also do is to update some of the values in a data table for a particular set of columns. So in this case, for the second and the third and the fourth rows, probably it matches the condition A is either 1 or 2, and then we are going to change the value of the column D to some other value. Or for the same condition or different condition, we could actually add a new column or a bunch of columns. Or we could ask for each of the unique values in the column A, do some operation on all other columns. So for example, the first one is 3, and the last row is also 3. So we'd like to group them together and then do some computations for just those two rows on the other columns, B, C, and T, and so on for the other values. Again, here we could have a subset of the columns returned for each group. We don't have to worry about the column D or B here. We just group by the first column, and then we compute the results for column C alone. And then a combination of both. You have a condition that only filters certain groups, and then on that you're going to do some computations grouped by some other value. And then the same thing goes on for groups, but instead of aggregating or returning a subset of the rows, we are going to update a particular column, or we are going to add a new column. So in essence, these are the kind of the most common operations that you can think of when you think of a two-dimensional data structure. And the exercises, the first exercise, for example, the 1 to 9, they basically follow this pattern. The first one selects the rows, subsets rows, the second one selects columns, and the third one, and so on. So what we're going to do now is to look at these four groups one by one, and using data table, and then for each of these groups, you'll be solving a bunch of exercises, and you'll have more time just to focus on just each of these groups. And of course, if you have questions, you can always ask us. Is that clear? Okay, so the exercise 1B, which I'm guessing most of you didn't get to, is the same kind of things, but instead of one table operations, you have the same kind of things, but with two tables. Now, instead of subsetting just the rows from one data table, you're asked to subset what happens if you have second data table and you have to use that data table to get a set of rows on the first data table and then do the same kind of operations. In any case, it'll get clearer as we go through each of these groups one by one. So this is more or less the outline which I just explained. So we're going to go through each one of these groups one by one, and then you'll be solving exercises which are very particular to that group. And then we'll just discuss through the answers. At the time, you can ask questions, and then we'll just carry on. So the most important thing to understand about data tables is that it has these three variables, or three placeholders, I, j, and by. And given a data table, most of your operations will always happen within this frame, this square brackets. And the first argument will always select the rows or give you the row indices on which you want to do further operations on. The second argument, which is J, will always compute on the columns for the rows that we just selected in the first argument. So if you did not provide anything in the first argument, then you're obviously going to operate on all the rows for whatever columns that you want to do in the second argument. And the third one is the group by. If you want to do those operations for every column, but depending on a certain group, then we will be using the third argument. So you can just go ahead and create the data table, DT1 and DT2, if you already have DF1 and DF2 in your workspace. And then we'll carry on from here. Okay, so the first group. So the first question was subset all rows where ID column equals 1 and code column is not equals C. So how many of you managed to get it using data table or base R or dplyr or whichever? So if you're familiar with data frames, then the most obvious difference would be that inside the square brackets you'd be using df$ID equals 1 and then df1 $code not equals C, right? So in data table, within the frame, the square brackets, you can refer to column names of data tables as if they are variables. So you don't have to do the DT1 and DT1 code and so on. And the second difference is that, so can anyone tell me what happens if you do exactly the same way, but with a data frame, but using df1 $ID and df1 code? How many of you think it would error? So why would it error? Sorry? Exactly. So in base R, the first argument, if you just provide one argument, it assumes that you're going to select the columns on it. So it would just try to figure out to subset columns from it. So in base R, if you want to get it right, you'll have to add a comma after this expression just before the end of the square bracket to make sure that you are specifying the first argument and not the default second argument. In data table, it would work the same both ways. You can add a comma if you like that form, or you don't have to. So it would just select these two, and then you get these results. Do you get the difference or the minor difference between a data frame and a data table? In data table, it would work if you just do $ID, but it's just not necessary. Is it okay? So I'm going to go on unless somebody just raises their hand. So select val A and val B columns from DF1, the second exercise. Yes? No, it's not a logical AND. If you use just one, it's usually element-wise. So here, the one AND just means that if you have a bunch of 5 logical values and a bunch of 5 logical values, if you use only one ampersand, it would just take the first and the first. But if you use double ampersand, you expect it to return only one value. It's a logical AND. It can be only true or false. Well, it depends on what you want to get. If you're using an if statement, then you want to get a single true value, so you just use double ampersand. And your condition should make sure that the double ampersand makes sense. So the question was the difference between a single ampersand and a double ampersand. And the single ampersand basically does an element-wise AND operation. So if you have a bunch of 5 values x and a bunch of 5 values y, x ampersand y would take the first element of x and then do an AND operation with the first element of y and so on. So you'd get 5 values in result. If you use a double ampersand, then you expect it to return a logical true or false, just one single logical value. Okay, so the second one, just to select columns. And here there's a difference in the way we normally use data table compared to a data frame. So if you use the data frame, you do df1 brackets, comma, and then C within quotes val A and val B to select the column names, right? In data table, by default, because you can refer to the column names as variables, what happens is you can, first of all, you don't have to use quotes because you can refer to the column names as variables. And the second one is you can pass in expressions in the second argument of data table. So here, what I'm saying is I want a list of values to be in the result, which is 2 columns, val A and val B. And what data table does basically is to evaluate this expression in the J frame. So it gives you val A and val B as a list of 2 elements. And each element of the list would become a column in the resulting data table. So basically, you'd get the same result, but the way it's happening is just that it's evaluating the expression. And as long as you return a list, it would take each element of the list, and that would become a column in your data table. So do you all understand what list val A, val B would give you in the result? Sorry, do anybody know how to increase the font in RStudio? Okay, got it. I'm sorry? Okay, so if you do list dt1 $val A, dt1 $val B, do you all understand what this is? It's just a normal list in base R, right? And if you do that in the argument in the J argument, which is the second argument inside of data table, you'd get a data table back. That's because it evaluates its expression, and then that gets this, and then each element of your list, which is this one and this one, they become columns in your resulting data table. So here, it's trying to identify the names of the resulting columns, but it couldn't. That's why it's automatically naming them as V1 and V2, because it's not the typical way we would use a data table. Now, if you do that, then it's able to identify that you're looking for val A and val B, and it automatically names them. In this case, it basically manages to find out that you're selecting val A and val B columns. So basically, you can pass expressions in J. Yes? You mean something like that? So it would just say val C is not found. I see what you mean. I see. So for example, something like that. So what it would do is to recycle the column that is shorter to the length of the longest column. And it would give you a warning that there's something that you have to take care of. Any more questions? Okay. So this is for selecting columns. And in the place of list bracket or list parenthesis, you can also use dot in place of list just for shorter typing. And the third one is to put them together, which is to subset rows where ID is greater than 1, and to select the columns val A and val B, but name them val A and val B, but to get the sum of those columns. So does this make sense as to why this is possible in data table? So in the second argument, you have these columns that can be referred to as variables. So you can pass expressions to it. So this is exactly the same as doing list dt1 $val A, and then doing a sum on top of it, or dt1 $ID greater than 1. Right? So there's the same result here. It's just it's possible to do it because first it identifies the rows where ID is greater than 1, So that would be the 5th, 6th, and the 8th rows. So this one, and this one are the ones where ID is greater than 1. And on those rows, it's going to evaluate these expressions. And that gives you some val A and some val B. And because I'm using a dot bracket, this is going to return a list of 2 values, each one of them of length 1. The first list element would have 19 in it. The second list element would have 46 in it. And so it becomes 2-column data table in the result. Sorry, who is asking the question? Yeah. Yeah? Yeah. Yeah, so the dot is basically an alias to list. So you understand base R list, right? So here you have list and then brackets val A and val B. So the difference between the two is that, so let me just show you how you would go about solving the same problem of subsetting the rows and then selecting or computing on columns using base R. So first you will have to do DT1 $ID greater than 1, right? So this would give you all the rows what we require. And then you will have to select the columns, right? And now you have to perform the sum, right? So you will have to loop through it and then call sum, right? And now you have a list, but you want a data table back. So you do, again, on top of it, what happened? Yeah. So we are here, and we get this, right? Instead of that, data table allows you to first remove the redundant DT$1. So that's where the I part gets simplified. The second one is, inside this, we could just ask the value of a variable without having to code them, because you can see them as if they are variables. So because I can see them as variables, I can directly compute on them within the bracket. We don't have to subset it first and then wrap it around another function. So that's the advantage of using it. So now if you want to do multiple things, so here I didn't wrap it in a list, and that's why I'm getting a vector back. So if I just did list, I would get a data table back, because you have a list of length 1, and that becomes a 1-column data table. And now if I do sum val b, become a 2-column data table. And then I can name them just like how I would name them in base R, how you would name a list in base R, and then you'd give the names to the columns in the result. Getting a little bit clearer? No? Yes? Sorry. I'm facing quite a bit of issues that I haven't faced in other places before. So, I'm trying to resize this thing and it's not working. Yeah, here we go. Yeah. So could you please remind me if I go too much on the, it's probably easier. I'm trying. Can we do that? The yellow button? This one? It would minimize. The green one would maximize. Okay, so I'll just move on to the next one. I thought I explained it. So basically, do you follow this much? So basically, you can just replace this list with a dot just for convenience. Yeah, it's just an alias. I mean, if you don't like it, just keep on using list. Really? Yeah, so we went through this one. And so exercise 1B, if you look at, well, you didn't get a chance to look at it, but if you go through the 10th exercise, then basically it's trying to subset a bunch of rows from the first data table, DT1, which is on the left, using another data table, which is on the right side. So it's interesting to think that if you're asked to subset rows and if you're given only one data table, we immediately go to the first expression and try to say x equals 5 or x is between 5 and 7 or something like that. But if you give the same operation and then give you another data table, the immediate reaction is to go to the base function merge, isn't it? Or one of those join functions in dplyr, right? You'd first try to get the full data table by doing a merge operation, and then you'd go to whatever result you want to get. So here, if you look at the second data table, the first row for ID and code, 3B, has no rows that are matching, and so are the other rows that are in red. The only row that matches is 1C, and that matches with the first, third, fourth, and the ninth rows. So basically, what we want is something like this. Corresponding to the first and the second row, we get an NA, and the third one matches all the 4 rows, so that's why we get 1, 3, 4, 9, and the 2C and the 3D will again give you no matches, so you return an NA. So in data table, you can do that exactly the same way that we have done so far, except that the I argument is now slightly different. So if you remember, the I argument always depends on, the I argument always results in subsetting rows, right? So you want to identify which rows you want to subset. So instead of a variable or a column inside of DT1, now you have a separate data table. So that should be fairly obvious as to why DT2 becomes the I argument. So instead of subsetting something within a data table, we have now another data table. Now the on argument here tells which column of DT2 do you want to match against which column of DT1. So basically the first line tells here, figure out by matching the ID columns and ID and code columns of DT2 with corresponding the same names in DT1 data table, and it will basically figure out which rows that match or don't match. And on them, you just subset or select the val A and val B tables. So I'm just going to go through this step by step to give you an idea as to what or how it's doing internally. So these are the 2 data tables. And so let me just do DT to on equals ID code. So this which equals true is an argument in data table. If you do, it would just give you the indices that match. So here it says NA, NA, 1, 3, 4, 9, NA, NA. So unfortunately, it doesn't also tell you which one it is matching to. It just gives you a vector, but we can figure out that the first NA corresponds to the first value of DT2, and this 1, 3, 4, 9 is the place where we are actually having a match, right? So what happens if I don't do this one? So it's going to subset those rows, and then we haven't provided anything for the second expression. So it's just going to return everything, all the columns. So it's returning me val A, val B, and the mul column also from the DT2. So these are the matches. For 3B, there is no match in val A and val B, but there is a mul column, so it's returning that. And these are the places where there is actually a match. Do you follow now what's going on? So once you have this expression and you know that this is going to select the rows for me, I don't have to be done there. I can actually, while the rows have been computed, I can do something else before returning the results. So that's what we are doing here. We are just returning the columns that we just need. We don't need the mul column or the ID or the code column. So we can do that directly to get just that. And similar to that, you can also do sum val A. Sorry. And you can also plot So basically, the J is truly a place where you can evaluate things as long as the column is available. So you can do pretty much anything you do in base R here as well. So if you do plot, then it's going to just plot val A against val B for just those rows. Yeah. This one? What happened? Sorry, I'm not good with RStudio, I'm sorry. Okay, so, sorry, yeah. So, sorry, 1 second, yeah? Yes, so this would be, I think, a right join. If you just did this, then this is an equivalent of a right join.
So when we do a base R merge, all to be true.
It would be all dot y equals true.
All dot y.
Yeah.
And if we have to do all to be true and all dot x.
You just reverse the, so if you want to do all dot x equals true, then you reverse the dt2 and dt1 positions. And if you want to do all equals true, you can't. So that would be the only place where you have to go for merge, because it's not a really, you don't want, there's very less cases or practically no cases where you have to merge everything and do computations on all of them. So at least I haven't come across it. Sorry, that was one of the. Yeah. Yeah, so the proper way, or the normal way to write it, if you don't name arguments, would be like that. Sorry. So this is the I argument, and then this is the J argument, and this is the additional on argument that you will have to provide to tell which data tables you're matching. I just wrote them together because I think they go hand in hand. It's easier to understand that you're first selecting the rows in the first line, and then, so because you use on, you're naming the argument as on equals. R understands that that argument is not the J argument. Yeah. Is it this one? Do you have, are you using data tables? Could you take a look at this? Yeah, so the point I'm trying to make here is that compared to base R and dplyr and SQL DF and other tools, one difference is that irrespective of, so we don't think in terms of functions when you look at the type of operation you want to perform. We always have these square brackets, and it boils down to which rows you're selecting, and then on those rows, what columns do you want to operate on? Do you want to just return the columns, or do you want to compute on the columns? This is the flow with which we'll be solving all of the problems. If there's a need for selecting rows, you know that the first argument is where you'll have to use whatever functions that you're familiar with. Okay, so if you don't, yes? So if you use merge, then well, compared to this one, the disadvantage would be that you can't do the selection during the same time. So if you had these two, then you would do merge dt1, dt2, all dot y equals true, right? Maybe, yeah, I think a lot of so this one, yeah? You mean like that? Well, it would work, but it won't take a constant. You can have, for example, ID is greater than ID, and that would work. So, but you can just add it separately, isn't it? Oh, I see you want to join and filter at the same time. Yes, but yes, so either you would do it this way, in which case you are actually getting a subset table first, right? You're getting a new data table, and on top of that, you're going to do the filtering. Or there are cases where you can perform a non-equi subset, where you can just say, see, when you're using another table, that means that you're depending on those tables' columns to do a subset operation, right? So in those cases, you could do something like this. But we'll come back to that. Okay, so if you have no more questions, or if you don't, just, yes? Very good question. That's what I forgot. Yes, so you could do, for example, ID equals ID and code equals code. So the left-hand side of the argument corresponds to the name on the data table on the outside, and the one on the right-hand side corresponds to the data table on the inside. So you could do, for example, this if DT1 had ID1 and code 1, and DT2 had ID2 and code 2. And you can also do this. You can also provide a character vector like that or like that. So basically you can provide the conditions in terms of an expression like a list or as a character vector. And once again, the dot here is an alias to list, so you can just do this as well instead of dot bracket. Is it okay? More questions? Okay, so now it's your turn then. So, probably I should explain something before doing that. So here, if I just did val A and val B, I get the bunch of NAs, right? So what do I do if I don't have any, I don't want any NAs in the result? So data table has this additional argument called no match, and by default it has this value NA. That means that irrespective of whether there are matches or not, I want the answer in the result. So if you set it to 0, then it would not return those no matches. So if I just remove this, it probably become a little bit more clearer. So here we are doing the row selection here, and it was supposed to return all the rows, even if there are no matches, and it's just going to remove the matches that didn't have any matches, and then return everything else. And one other thing what we can do is, so if you look at DT1, where ID is 1 and code is C, there are 4 rows, right? So what happens if I just want to return the first row or the last row? Usually those are the more common situations. You might sometimes require just the top 2 rows, but we'll get to that later. So in that case, you can do mult equals first, and that would just return the first matching row. So if you look at DT1, the first 1C corresponds to 1 and 10, right? And the default value of mult is all, and that's why we get all the values. And there's one more value for mult, which is last, which would return the last value of it. So basically, in addition to the first argument, you have 2 more arguments, which are no match and mult. And if you want to get an idea of what is happening, you can also use the argument verbose equals true, which would give you a little bit of internals as to what it's trying to do. So we'll discuss about these things after. In this case particularly, it's not so useful, but there will be cases where the verbose output will be quite useful. Okay, so what do you think would be the expression to get this answer? At least one of you should make a guess. I'm not moving. It's very similar to the first one, except you just need the first row. Sorry? Yeah. So you just add the mult equals first to it from the previous code, which I just showed like 2 seconds ago. Okay, so try to go through these questions. You'll be given 20 minutes. So this is kind of the basic thing to understand about data table. From here on, things will depend on this, so take your time to solve these. And if you have any questions, feel free to ask. So has everyone gotten past question 5? Or on question 5? Okay. So what about the others? How many of you have given up? Everyone's trying? So how many of you have gone past 3rd? Okay. So you have about 10 to 15 minutes. 10 minutes, but if you want, you can try during the break as well. Yep. I'm just going to announce it just because I just want everybody. So, at 3:35, we'll have a 30-minute break, or probably 20 minutes, if that's all right. And then we'll come back here to continue with the same tutorial for another 1.5 hours, right? That's if you want to continue. Yeah. So it's 3:27 now. At 3:35, we'll take a break, and then 3:55, we'll come back, and then we'll continue with the rest of the topic.